Hey, Year 8s, let's get ready to take up assessment number 2. Before we do that, I just got to say that the questions that you seem to have the most difficulty with, and this is no surprise because I noticed this in class as well, was the graphing lines and the equation of a line, as well as sequences and the nth term. So as we're taking this up, make sure that you understand how we're taking it up fully, because we're likely to see these kinds of questions again on assessment number 3. Also, the questions at the end of this assessment, the ones about angles, they were fairly basic angle questions, so you're likely to see some more challenging angles questions on assessment number 3 as well. So let's get started. Looking at question number 1 here, like I said, this is equations of a line, and you should be used to this format of an equation of a line. Y equals mx plus c, where m is your gradient, so that's the steepness of the line. If that number is positive, the line should be sloping upwards, the way I'm pushing my cursor that right now. And C is your y-intercept. That's where your line crosses the y-axis. So if that's a positive number like positive 9, for example, it's going to cross your y-axis up here. If it's a negative number like negative 5, for example, it's going to cross down here. Okay, so starting with this first line, y equals 7. It doesn't even seem to be in this format. It's just y equals a number. There's no x there at all. So let me just show you on my table of values over here that I set up. Now you don't need to do a table of values for these, but if you're having trouble understanding what that's going to look like, it definitely might help. Let me just set this up here. So if x is equal to 0, the rule is y is equal to 7. Now if x is equal to 1, the rule doesn't seem to care. Y is equal to 7. If x is equal to 2, y is still 7. If x is equal to 3, guess again, y is still 7. So if y is always 7, then it doesn't matter what the x value is. The y value will always be lined up with this 7 here on the y-axis. Let me show you that graph now. So if I'm going to plot these points, 0, 7, that's the point 0 coming up to 7 here. 1, 7 is going over to 1 and up to 7, that's there. 2, 7, 2 up to 7 is there. And 3, 7 is 3 across, and 7 up, it's there. So if I draw those, or plot those points and draw the line in, you're going to have a line that goes across like this. Right? That's the line y equals 7. It doesn't slope upwards, it doesn't slope downwards. Its steepness is actually 0, which is why there's no x term in this formula of the line. It's just y equals a gradient of 0, a steepness of 0, which is flat, plus 7. So y equals 7. That's a horizontal line. That's this one here. Okay, let's go on to the next one. Y equals x. Now y equals x. Again, I'll go over here and I'll show you what that's going to look like. Again, I always start out my table of values where x is equal to 0, 1, 2, 3. I always start with those numbers because they're the easiest numbers. They're nice small numbers, so they're easy for me to work with. Okay, and then I'm going to find the y values that go along with these. So over here, I'm putting in my y values, and if y is equal to x, then y will be the same thing as x. If x is 0, y is going to be 0. If x is 1, y is also going to be 1, because the rule is y is equal to x. Y is the same thing as x. If x is 2, y is also 2. If x is 3, y is also 3. Let me show you what that looks like as a line. So I've got a line here. I'm going to go through 0, 0, which is this point here, and 1, 1, which is this point here. 2, 2 is this point over here, and 3, 3, that's this point up there. Right? The y values are the same as the x values. So if I just draw that line in, and that line goes on forever in both directions, so I'll stretch it out in this direction as well. Always going through those corner points where 1, 1, 2, 2, 3, 3, the x and y coordinates are the same. That's an upward sloping line. But it's not crossing above the x-axis, nor is it crossing below the x-axis. It's crossing right at the x-axis. That point 0, 0 at the x-axis, we call that the origin. Okay, so that is this one here. There we go, the origin. And I'll go ahead and join those up. Upward sloping line crossing through the origin. Our next line is y equals 3x minus 2. Again, look at the equation of the line. You might be able to guess at which one that is right away. Y equals 3x, so 3 is the gradient. That's a positive gradient. That's an upward sloping line. It's not going to be the downward one, and it's not going to be the vertical one. It's an upward sloping line. And our y-intercept, the number that's added on, is actually negative 2. So c is negative 2. It's going to cross the y-axis down here at minus 2. I already know what that's going to look like. I know that that's going to be an upward sloping line crossing the y-axis down here at negative 2. But I'm going to go ahead and show you on our table of values over here. Let me set this up. I always set up my table of values. X is equal to 0, 1, 2, and 3. And I find the y values that go along with that. So following this rule, this one's a little bit more interesting this time because our y values are not equal to our x values. Our y values aren't always the same. Our y values have to be calculated using this formula. So y is equal to 3 times the x value minus 2. If the x value is 0, as it is in our first value in the table of values, y is equal to 3 times 0, which is 0, minus 2. 0 minus 2 is negative 2. So my first point is negative 2. 0, negative 2. Okay, when x is equal to 1, I go over here again. I substitute a 1 in for the x. And so I'm doing 3 times 1 is 3 minus 2. 3 minus 2 is 1. So when x is equal to 1, y is equal to 1. That doesn't mean it's the same as the line above here. It does have one point in common, but not all of the points in common. So let's keep going. If x is equal to 2, over here, I replace the x with a 2, so that's going to be 3 times 2, which is 6. And take 4 away from that. Sorry, 2 away from that. 3 times 2 is 6, minus 2 is 4. Right, so when x is equal to 2, y is equal to 4. Finally, last point that I'm going to put in my table of values, when x is equal to 3, I go over here, I replace the x with 3. 3 times 3 is 9, and I'm doing 9 minus 2 is 7. So when x is equal to 3, y is equal to 7. And I'll show you where those points are going to be on my graph. When x is equal to 0, y is equal to negative 2. When x is equal to 1, y is equal to 1. That's this point here. When x is equal to 2, y is equal to 4. That's this point up here. Notice that as I plot these points, and I'm doing this with a straight line, they are all staying on that same straight line because they follow this rule. When x is equal to 3, y is equal to 7. Does that follow the rule, 3 to 7? It should. And that rule goes on forever in both directions, so I can continue going upwards. Notice my pattern here that these numbers are going up by 3s because our gradient is 3. So is my line. It goes across 1 and up 3. So if I want to stretch this line out, I'm going to continue. I'm going to pull it over 1 and up 3. And if I want to stretch it out in the opposite direction, I pull it over, pull it over 1 and down 3. Over 1, down another 3. Okay, it still should be going through the points that we plotted. 0, negative 2, 1, 1, 2, 4, 3, 7, and so on. Okay, so let's join that up. That's a positive sloping line with a bigger gradient than the other one that we drew. It's got a gradient of 3, so it's steeper, but it crosses down here at negative 2. Upward sloping line crossing the x-axis at a point, crossing the y-axis, sorry, at a point below the x-axis. That's this third one here. So we'll join that up. And let's go on to the next one. Y equals 2 minus 3x. Now this doesn't seem to be in the right order here. So it's important that you notice which number is with the x. And it's the minus 3. The sign is important. We've got a minus 3 gradient because it's multiplied by minus 3. That means it's a downward sloping line. I already know which one that's going to group with. A downward sloping line. Let's just read the rest of this description and see if it's right. It's a downward sloping line crossing the y-axis at some point above the x-axis, so having a positive y-intercept. Now this is all written backwards, but it has a positive 2 here that's added on, so C is positive 2. It's going to cross the y-axis at positive 2. Right, let me just fill in my table of values to show what that's actually going to look like, but I already know that this is going to be C. So going over here, I'm going to do my table of values, again, starting always with the x values being 0, 1, 2, and 3. And my y values, I'll put down here. When the x value is 0, I have to figure out what the y value will be. Following this rule, if x is 0, the y value is going to be 2 minus 3 times 0. 3 times 0 is 0, so it's 2 minus 0. 2 minus 0 is 2. Next, when x is equal to 1, I go over here and I replace the x with a 1. So this is 2 minus 3 times 1. That's 2 minus 3, which is negative 1. So when x is 1, y is negative 1. Next, when x is equal to 2, I'll replace this x with a 2. This is 2 minus 3 times 2. 3 times 2 is 6, so that's 2 minus 6, that's negative 4. And our last one for this table of values, when x is equal to 3, I'll replace the x with a 3. 2 minus 3 times 3, that's 2 minus 9, and that is negative 7. Notice the pattern in my numbers here, just like in my sequences. My numbers are going down by 3s. So will my line will go down by 3s. Let me show you how I plot my points. So get my line ready. I'm going to plot the point 0, 2. That's this point here. I go across to 0 and then up to 2. That's here. And then I'm going to go across to 1, negative 1. That's this point here. Then I'm going to go across to 2, negative 4. So I'm going 1 across and 3 down to negative 4 there. And next point is 3, negative 7. So I go across 1 and down 3 at 3, negative 7. So that's my line y equals 2 minus 3x. It crosses the y-intercept at 2. And as I go across 1, I go down 3. I go across 1, I go down 3. And this line goes on forever like that. So I'm going to stretch it out again a bit. Go across 1 and down another 3. And by doing that, I haven't lost any of the coordinates I previously plotted because all of these coordinates follow that same rule. I'm going to go across and again 3, across and then again 3. And if I'm lining that up right, I still have all these same correct coordinates. 0, 2, 1, negative 1, 2, negative 4, 3, negative 7. They're all still there on that line. So let me draw that line over here. This is a downward sloping line crossing the y-axis at some point above the x-axis. It has a y-intercept of 2. And this last one, well, it's the only one left. It must be this vertical line here. Oh, that was blue. Let me draw this last one. I'll put this one in purple. It's got to be that vertical line when x is equal to negative 2. Now, this is the one exception. When I do my table of values, I always like to start with the values 0, 1, 2, 3 for x. But in this case, the rule tells me that x is never 0, nor is it 1 or 2 or 3. It's always negative 2. So if x is negative 2, x is negative 2, x is negative 2. No matter what y is, x is always negative 2. So I'm doing this one a little bit different from the other ones because here I'm going to put the y values in. I can choose any values I like for the y values because the y values will always be, or the x values will always be negative 2 regardless. So y is 0, 1, 2, 3. I'm just choosing nice easy values for y because it doesn't matter what y value is, x value is always negative 2. Let's draw what that looks like. So when y is equal to 0, x is negative 2. X is negative 2, that's here. Y is 0. When x is negative 2, y is 1. When x is negative 2, y is 2. When x is negative 2, y is 3. That's this straight line going up here. Let's put that in purple. Okay, and it continues like that forever. X is always negative 2. That's a vertical line lined up with the negative 2 on the x-axis. So it goes up and down forever. After what we've just done up there, you should be getting used to seeing the patterns in the table of values, and from there you can work out what's the rule here, what's this graph going to look like, and what's its equation going to be. Okay, so looking at this table of values, again, x is 0, 1, 2, 3. That's to make it easy for you. I always choose those values. But my y value is 5, 3, 1, negative 1 has a little bit more of an interesting pattern there. What do you notice about those numbers? They seem to be going down, right? 5 to 3, that's minus 2. 3 to 1, that's minus 2. 1 to minus 1, that's minus 2 as well. It's always going down by 2's. So that means my gradient is going to be minus 2. It's going down by 2's. And when I draw that line, you will see that the line goes down by 2's. Okay? The other thing that you should notice directly from this table of values is when x is equal to 0, y is equal to 5. That's my y-intercept. So my y-intercept is 5. If that's the case, I can go ahead and draw that graph, and you'll see that I'm plotting these coordinates here. I'm going to go through the point 0, 5. Where's my line here? Going through the point 0, 5, which is up here. The next point is 1, 3, which is there. The next point is 2, 1, which is there. And my next point is 3, negative 1, which is there. So that's my line, y equals minus 2x plus 5. You can see that it crosses the y-axis at positive 5. And every square I go out to the side, I go down 2. Out to the side, down 2. And this pattern goes on forever. Out to the side, down 2. So if I want to continue this line on forever, I just have to keep going out to the side, down 2. Out to the side, down 2. Out to the side, down 2. And I won't have lost any of my coordinates because every new coordinate I plotted followed that same rule. Every step I go out to the right, I go down 2, negative 2 gradient. Okay. Let's go on to question 3 then. Here you've got some graphed lines, and once again we just have to match them with our equations. So I don't have to graph these for you, but we can easily look at the equation of a line based on the y-intercept and the steepness of the line. Now starting with the line 1, the green one, it crosses the y-axis at 3. So I'm looking for an equation here that has plus 3 on it, and I see 1, 2, 3 possibilities. So the other thing I need to know is what's the gradient. As I go across 1, I go up 1. That's a positive 1 gradient. I go across 1, I go up 1. If I went across 1 and up 2, that would be a 2 gradient, but this is a gradient of 1 because I only go up by 1's. My steepness is 1. So this equation of the line should be y equals 1x plus 3. That's this one here. So in green, I'll join the green one up. Y equals 1x plus 3. I don't need to write the 1 in front of it because it's a single x. Okay, the next one in pink is this one here, and I can already see what the y-intercept is. That's the easiest thing for me to find. It crosses the y-axis at minus 2. So let's see, do any of these cross at minus 2? This one does. That's the only one. That's got to be it. So I'll go ahead and draw that one in, and I'm just going to double check that it's got the gradient that I'm expecting. It crosses the y-axis at negative 2. Every step out I go to the right, I have to go up 2. That's a gradient of positive 2. I go out to the right 1 and I go up 2. So yes, that's the equation y equals 2x minus 2 because the y-intercept is minus 2. Next one's the red one, and the red one seems to be going downwards. So I'm looking for a negative gradient on this one. It's going downwards as I go across to the right. And my y-intercept, the easiest thing for me to find is where it crosses the y-axis at 2. So for the red line, I'm looking for a y-intercept of 2 and a negative gradient. So I'm looking here. That one's a positive 2 y-intercept and a negative 2 gradient. It could be that one. Or that one's a positive 2 y-intercept and a negative 1 gradient. So I need to look closer at that gradient then. It starts here. If I go across 1, I go down 1, not down 2, down 1. So my gradient is negative 1. Let's try that again. If I go across 1 square from any point on the line, I have to go down 1 to get back onto that line. The steepness of the line is negative 1. So the equation of the line is negative 1x plus 2. Right? So I'll draw that on. I'll make that red. And our last line, the line number 4, the blue one. I can already see this number up here is a 3. That's not 3x. That is something plus 3. My y-intercept is 3, so the number I'm adding on at the end is 3. Could be this one. This one I've already used, or it could be that one. So y equals minus 2x plus 3, or y equals 2x plus 3. The big difference between these two is one is positive gradient, that's this one down here, and one is a negative gradient. And my line here, this blue line, I hope is obvious to all of you, is a downward sloping line. So it's a negative gradient, and it's a negative gradient of 2 because any point on the line, any point I choose, if I take one step out to the right, I fall down 2. One step out to the right, I fall down 2. So it's a negative slope of 2. Y equals negative 2x plus 3. I'll draw that on. I'll make that blue. And that's it for question number 3. On to question number 4. Okay, this should be a nice, quick, easy one. At least filling in the next 2 terms, that wasn't a problem. It was figuring out the rule, and generally you could find the common difference, but finding the adjustment was the difficulty. So let's see if I can help explain this to you a little bit better. Right, here I can definitely see 4, 7, 10, 13. It's going up by 3, so the next 2 numbers are going to be 16. And then after the 16, another 3 more is 19. Okay, the nth term rule then is jumping up by 3, so I'm going to write 3n. But the difficult bit was that this is not the 3's times table. This is 1 higher than the 3's time table. I need to do 3 plus 1 to get that first term, so I'll write my adjustment is plus 1. Okay, the next one, negative 11 minus 5 plus 1 plus 7. These numbers are getting bigger. They're getting less negative, and then they're getting bigger. And the rule is always the same for all of them. I can tell what the rule is here. From 1 to 7, it's plus 6. Let's just double check. Negative 11 plus 6 is negative 5. Negative 5 plus 6 is 1. Yes, I'm always plusing 6. So 7 plus 6 is 13. 13 plus 6 is 19 again. And I can tell you my common difference is plus 6. The common difference I don't think was the problem. We could always see what we were jumping by. This one's going up by 6. The adjustment was the difficult bit. Now, especially with this one with a negative number here, I need to take a lot away from 6 to get that negative 11. Think how much I need to take away from 6 to get to negative 11. I need to take away 6 to get to 0, and then I need to take another negative 11 to get to negative 11. So minus 6 minus 11, that's minus 17 altogether. Okay? And if you want to try looking at this a different way, if you think what was before that number, I'm constantly adding 6 on. So before I added 6 on here, what was 6 less than that? It was negative 17. So you could always think for my adjustment, it's the number that would have come before the first term. Right? Last one, and this one I think was the hardest one for some of you. 14, 4 minus 12. Was that a difficult common difference to figure out? It's definitely going downs. 12 minus something makes 4, or 12 minus 4 would give us the difference. It's 8. So 12 minus 8 makes 4. 4 minus 8 makes negative 4. Negative 4 minus 8 makes negative 12. Keep going minusing 8, so that's going to be negative 20. Minus another 8, that's minus 28. And my nth term rule, we know the common difference now is minusing 8. So that bit should be the easy bit. The difficult bit is the adjustment. Okay, I can see that my sequence doesn't start with minus 8. It starts a lot higher than that. So I need to add a big number onto minus 8 to get up to 12. Or you can use that other trick. What would the number before 12 have been? If I added 8 to get to 12, take 12 away from 8 and see what would have been before that. It would have been, oh sorry, I'm taking away, so add 8 to 12. That's 20, right? Negative 8 plus 20 gives us 12. Okay, on to question 5. Here you've got a line. The axes aren't labeled though, so we don't know for sure what the equation of this line is, but we know one thing. It's got a downward slope, so the gradient is definitely negative. So I'm going to look here, and I'm going to eliminate the numbers I know, the equations I know are wrong. This is a positive slope, so it's not that one. This is also a positive slope, so it's not that one. This last one's also a positive slope. That made that easy for me. It's got to be this one. It's the only equation with a negative gradient. It's a downward sloping line, and this says that it's got a gradient of negative 1/2. That makes sense because every square I go out to the right, I go down 1/2. Or if I go 2 squares out to the right, I go down a whole. So I know that that is 1/2. It's a negative 1/2 gradient. And the y-intercept here, it says it's 2. And that would make sense. Even though it's not labeled, that makes sense that if this was 1, this would be 2. Provided that this is going across 1 and 2. That would show that I've got my y-intercept of 2 and my gradient of 1/2, because I go down 1/2 every time I go across 1. So that one is C. Next question, again the equation of a line. Is the gradient of this line positive or negative? Now I'm hoping this is easy for us now. It's definitely a downward sloping line, so it's negative. What is the y-intercept of this line? Where does this line cross the y-axis? Again, that should be easy and obvious for us. It crosses at 3. Okay, and is 5, 2 a point on this line? 5, 2. That's going across to 5 and up to 2? Yes, it is. That's this point here. Yes. And is 110 on this line? 110. 10, 1 is on the line, but that is not 110. 110 would be across 1 and up to 10, which is way off the graph. It's not a point on the line, so no. Question 7 is the last one that we actually had difficulty with. The last 2 questions were actually a lot easier. 3 questions, sorry. But question 7, you are likely to see another question like this on the next assessment, so let's be careful with it. The home value has decreased by 20%, so I do 100% minus 20%. What percent is left? That is 80% of the 108. I'm doing 80% of 180,000. 80% of 180,000, oops, let me just fill in that of, means 80% times 180,000, but it's probably easiest to convert that to a decimal. 80% is 80 divided by 100, that's 0.8 times 180,000. And you can go ahead and calculate that out. That's going to be 144,000. Next question, question 8, went pretty well, so I'll just go through this really quickly. 1/5, if I write an equivalent fraction to that, would be the same thing as timesing the top and bottom by 2. That would be 2/10. And 2/10, that is, as a decimal, 0.2. Right, 2/8, that could be easily simplified. That would be dividing top and bottom by 2 would be 1/4. And 1/4 we know is 0.25, or 25%. A 50% increase is 50% more than 100. So that's 150%. And 150%, if I convert that to a decimal, would be 1.5. And this last one here, it's got to be 2. But if I do 150 divided by 75, it's 2. Again, these last 2 questions were easy questions. Don't expect that on the next assessment. Now that you have a better grasp of parallel lines, we should be able to do more than just this. But true or false, x and y are alternate angles. Alternate angles are the one that make a Z pattern. So a Z pattern like that. I'm having trouble here with the clicking there. Okay? And x and y don't make a Z pattern. If I draw this for you, x and y, I'll draw one line there to trap x in that angle. And then I'll draw another line here to trap y in this angle. I didn't draw a Z. What did I draw? I drew a C. And C patterns are not alternate. They are interior angles. The other pattern that we didn't see here is an F pattern. And an F pattern, those are corresponding angles. So this is not alternate angles. This is interior angles. So let's go ahead and mark that false. Okay, last one, question 10. This is not to scale at all. Don't ever expect to be able to measure it. And look, that's definitely not 58 degrees. So when you're looking at x and you're saying, oh, x is so much smaller than this one, it should be smaller than 58. No, we should be thinking x plus 58, make a straight line so they add up to 180. So x must be equal to 180 minus the 58. So that means that x is an obtuse angle, although it doesn't look it. X is 122. So x here is 122. Y, you may not have noticed this, but I don't need to do any working here. I can see it directly. It makes a pattern with the 58 degrees. I'll draw the 58 degrees inside those lines, and I'll draw the y with these lines. Oh, that wasn't very straight. I should use a straight line. Right? Do you see what pattern that makes? It looks a bit open, obtuse, but it is a Z pattern. So in a Z pattern, they're alternate angles, so y is simply equal to 58. And it doesn't look it at all because it's not to scale, but it is equal to 58. And finally, Z. Z makes a pattern with the X. Let me draw that on in a different color. So Z and X. I'll draw the X between those two blue lines and the Z between these two blue lines. You can clearly see what pattern that makes, right? That's a Z pattern. Those are alternate angles, and X is equal to Z. Z is equal to X. I already worked out what X is, so Z is 122.